You're muted, but you're good.
Got it. Hey everybody. I'm going to get started here. So let's run through this, and I'm going to go through kind of a top level down from like what is DevOps and what are the different pieces of it. And then I'll get to some practical examples towards the end, and then we can switch over to like GitHub and walk through some stuff in a public repository. So DevOps, it's kind of about going fast. I just wanted to start really quickly with who I am. I'm Josh Hayes-Sheen. I'm a staff software engineer at Varsity Tutors, also called Nerdy. I've spent about 12-ish years building and shipping software, mostly at companies that practice like a DevOps culture. And there's some contact details in here. I can share at the slide deck later. I'm also going to say that I'm involved with our local Sault Ste. Marie developers group and the Dev Drinks events. And you should come on out and hang out with us and join our Discord if you're interested in software development and kind of connected to our local area. So I wanted to start off with this kind of really top level, what is DevOps? And this is something where there's like 100 companies that will sell you their definition of DevOps, and they will sell you a tool set that matches their definition of DevOps. So the one that I chose, my poison, was AWS, Amazon. This is their definition. So DevOps is a combination of cultural philosophies, practices, and tools that increase an organization's ability to deliver applications and services at high velocity. And I'm going to come back to this definition a couple of times, and I'm going to dig down into kind of each of the points of this definition as well, kind of as we go through here. So, again, DevOps, like what are these different things? The two different pieces are, development and operations, which historically have been two separate groups. In a lot of cases, these used to be two fully staffed teams of people. You could be talking about like 10 people or more to like run these two different sides of things. Development is really kind of responsible for planning software, for actually writing it, for verifying that it's going to work as expected, and then for packaging it in a way that it can actually be run. And then operations was responsible for running it. So they were responsible for kind of taking that software, putting it on computers, for other people to access. Sometimes they had to allocate those computers, they had to buy them. Sometimes they had to build and install them, things like that. They're responsible for running the code. So usually this means, kind of starting it up, making sure it's available. Monitoring is a big piece of that, knowing if it's, running properly or if it's fallen over and needs someone to go in and like restart it or something like that. And these two things, they tended to be very separate. Software developers would kind of, they'd kind of write their code, they'd write their feature, and they kind of chuck it over the wall. And that was kind of the last that they would hear about it. And there's like problems with that, right? So when we talk about combining these two things together, is it just kind of more people or fewer people doing more work? And that's not really what it is. It sort of is though, right? But the truth is that there's actually less work to do now than there used to be. So automation reduces the amount of work that people have to do to kind of run and deploy software today. Cloud computing reduces the amount of work. You don't have to build and rack a server most of the time. You have to kind of click a few buttons in a console and you're done. And a lot of modern tools and practices reduce the amount of work that's there to be done. So really, you're just kind of getting more done for the same amount of effort or less. That's kind of the goal of this. It's not just about taking that 10-person team and making it a 5-person team and doing the same things. The other thing I wanted to answer here is like, why do we want to deliver software at high velocity? What does it mean to deliver software at high velocity? Customers expect fast updates. I don't know if anybody here, if you're playing games and you read the patch notes whenever they come out, and you'll see patches coming out, every 2 weeks, making little balance changes, fixing irritating bugs, adding new content, things like that. It really, to really show off my gray hair, you used to get those updates, you had to download them, you'd get them on CDs. There was a lot of enterprise software where they would mail their software to people because the internet was not at a place where you could deliver software over the internet the way that we do today. And the way that we deliver that today, it's just kind of what people expect, right? People expect bugs to get fixed. They expect patches to their software almost every day. They expect if they are an enterprise customer or business customer and they report a bug, they kind of want to see that bug fixed generally pretty quickly. So it is important to kind of move quickly, and if you move slowly, your competitors can take advantage of that. And that is kind of what happened, is that a lot of companies were forced to move faster, because anybody who moved slow, that company just died. They got beat by their competitors who were delivering more things faster, while they were kind of standing still. So then how do we deliver software at high velocity? How do we do that? How do we go quickly and not break things all the time? This is something that I feel like is kind of confusing to people. Is you get new developers and they sit down and it's like, yeah, we're going to ship your code to production like today, on your first day. You're going to make a change and it's going to go out in front of our customers today. And I think people panic, right? Of like, oh my God, I'm going to break things. Like, how do I do this and not just break everything all the time? And the answer is that it's actually a really positive feedback loop. To deliver things faster. The way that you do things to deliver things faster, inherently it makes them safer in a lot of ways. And then when you're doing things that make delivering software safer, that inherently makes it faster to deliver at the same time. So I kind of have a bullet point list of examples here. If you get faster feedback from customers, you can correct mistakes faster. So if you make a mistake, but you get feedback about it immediately, the impact of it is reduced by a huge amount. You spend a lot less time building the wrong things, which is a huge risk. And that's something that companies still get wrong, every day, is they spend a ton of effort and a ton of time building something that is not the thing that they need to build, not the thing that their customers need. So by getting things kind of shipped and in front of customers very quickly, you reduce the risk of wasting your time on building the wrong things. Faster security fixes, I feel like that one should be pretty obvious. If you can ship code to production in an hour, when that email goes out or that thing hits the front page of the internet that says like, hey, new security bug, wrecking everybody's stuff, you can fix it very, very quickly compared to a slower system that might take weeks, and you might be vulnerable for weeks or have to take your system offline, for several days to make sure that your customer's data isn't being leaked. And then automation, right? A key part of this that I'm going to go back to over and over again is making things automatic, making things scripted, letting the computers do the work. That's more reliable than humans, which makes it safer. It's both faster and safer. Humans make mistakes, they get tired, they get lazy, and they make errors that cause software to fail. But if you automate those things, the types of mistakes computers make are very different from what humans make. And we can kind of come back to that a little bit as well. And then, yeah, like I said, delivering, it is a positive feedback loop. So once you are delivering things faster, and that is kind of making things safer, when you know that you have that safety baked into your process, you can go faster and faster and faster as well. So you have more confidence to make changes. You're not sitting there on a growing pile of changes waiting to send them out to your customers because you're anxious that they might break something. I don't want to do this on a Friday. I don't want to get called in over the weekend because I'm worried that these changes are going to go out and they're going to break things for our customers. Knowing that you have this kind of these safety mechanisms in place means you can just keep going faster and faster. You can ship every day, ship every hour. You know that you're going to get that customer feedback faster. So if you break something, you're going to hear about it right away, which is both faster and it lets you go faster. It's easy to correct failures or back out mistakes. If you do break something and you get feedback from your customers that they hate this thing or that it's broken, you can revert that, and you can do that in a couple of minutes, which is super empowering. And then, yeah, back to the automation thing. Automation is faster than humans. Computers do things faster than humans. That's pretty obvious, I think, to all of us. I did my best to extract this core philosophy of DevOps, and this was something that every company will have their own, description of this. I thought this was a pretty good one. Creating a fast, low friction, and positive feedback loop between users and developers. And specifically with DevOps, you're going to be doing that by removing the barriers between those dev groups and those ops groups. So again, I think I'm going to come back to this one as well, because I think it'll make more sense as we go through more of these pieces here. So coming back to this definition, what is DevOps, right? So now we kind of know the history of why people might want to operate like this, why we might want to deliver services at high velocity. We understand that there's a philosophy here that is about getting to that kind of high velocity, a philosophy to get to high velocity. I should have rhymed that out before I wrote it down like this. So let's talk a little bit about the practices and the tools that help get you to that point. So the kind of key practices of DevOps, and again, this list will vary from company to company who is trying to sell you their kind of take on this, but generally, again, I thought this was a pretty good view on it. Key practices of DevOps, these are kind of the top level things that you do to operate in this way. And then I'll talk about a couple of tools that specifically help with these practices. So the key practices, you want to work in smaller units of change. I'm going to break out more on each of these as well. So you want to work in smaller units of change. That's faster than working on something gigantic and trying to ship it all at once. As you break it into smaller pieces, you can ship those smaller pieces more quickly. You want to collaborate across silos. This one sounds kind of corporate speak. I'm going to go into it a little bit more, but again, very specifically, those dev and those ops teams, they kind of need to be one team. You kind of need to be not having barriers in between these different kind of groups, in between the developers and the users, because every kind of barrier in that group just slows things down, adds friction to that feedback loop. Automate. Automation is like a key thing that has made a lot of this practical when it was not practical in the past. Microservice architectures, it's almost a buzzword today, and when I talk more about that, I'm going to throw up a huge bunch of warning flags, because there's a lot of companies that have really hurt themselves by adopting microservices without adopting a lot of the rest of the DevOps practices. So they can be dangerous, and there is a wrong way to do microservices. So you kind of do have to watch out for that. I'll talk a little bit about infrastructure as code. I don't know if anyone here is familiar with that term, but it is largely about kind of applying software development practices to how you deal with the infrastructure that your code is deployed onto. So if you say that you need 5 computers to run this code, or you need these 2 databases or something like that, you actually describe that in the code alongside your software. And by doing that, you get a lot of benefits, like you can apply automation to it, you can version it, you can roll forwards and backwards if you need to. You can do things like code reviews on changes to the hardware that runs your application. So this is really bringing that like operational practice into the development side of things and getting the benefits that you would normally get out of software development tooling with it, which is pretty great. And then monitoring, right? Again, part of that feedback loop is you must hear from your users. You must know how these things are working. Some of that is going to be direct user feedback. Some of that is going to be, hey, this thing that it's just computer recorded. This thing that used to take 2 seconds, now it takes 5 seconds. I don't need to hear from a user to know that that's worse. And getting that feedback immediately within like minutes of deploying your code, your changes to your code, is super important in making the rest of this work properly. So talking about smaller units of change, right? Like I said, you want to ship features in smaller pieces. Something that the industry has become really aware of over the last couple of years is that the longer that you spend working on changes before you're actually running them and before they're in front of your customers, the more risk grows with those changes. There's more risk that you're building the wrong thing. There's more risk that you're changing too many things at once. And if something breaks, it will be much harder to determine what broke, because instead of 50 lines of code changed, you've got 50,000 lines of code changed all at once. And understanding what could have broken there becomes that much harder, right? And then deploying those changes, right? It's kind of the same thing of like, do you want to deploy 5 or 10 line changes every half an hour, every hour, or do you want to deploy a week's worth of changes all at once and then have to understand how everything all changed at the same time? That feedback loop becomes much harder with those larger kind of units of change. Collaborating across silos, I kind of mentioned, dev and ops, they're the same group of people now. Something that was really common, and even today I think companies struggle with it to some degree, is waiting for permission. Asking for permission is historically super slow. If you need to add a new feature to your app and you have to submit a ticket to your IT department and wait several days for them to grant you permissions to either go monitor this thing or to allocate this infrastructure or some other thing that you need to do, it is super slow. So a key part of this collaboration is empowering developers to have all of the access that they need. This is, I think, where a lot of companies get things wrong, is it's not just about giving everybody all the access. In a lot of cases, it's around putting things behind automation, right? So if you don't want every developer to have the ability to spin up a new database server, you can spin that database server up based on infrastructure as code. You can have that infrastructure as code go through code review and require approvals, and even require approvals from your infrastructure group, from your IT department, or from some other group who still wants to have a human in the loop. But the difference between them going in and like checking a box in response to this code review going up and being able to see at a glance all the changes that are being proposed and know that that's what the production environment's going to look like, versus submitting a ticket and having to have a conversation back and forth of like, we think we need a new database. I don't know what size it should be. Do we need to turn this option on or off? It just speeds things up like crazy to have that access across the board as much as you can and to automate through that whole loop as much as you can. I also want to call out in terms of collaboration that this kind of goes both ways as well. Software that sucks to run, it should make things suck for the people writing that software. And this is also something that historically was not always true. A lot of developers, they would write software that sucked, and then they would hand it off to a team that then became responsible for running it. And there was a lot of resentment that could grow there, and those developers never got the feedback that they needed to write better software. So if you have things like, hey, this software crashes all the time, it runs super slow, it is very hard to configure, it requires a lot of like constant attention and maintenance and stuff like that all the time, there were whole development teams who had no idea of that situation because they weren't the ones running their own code. So again, a key part of this, practices of DevOps is making sure that the people who are writing the code understand if their code sucks to run or not. Because they can't just be disconnected from that. They have to get feedback in order to be able to correct it. To have a real cycle and to actually fix the problem, they have to be able to know and feel that pain. There's a link in the references here that I really loved about that, about developer sympathy, how they should feel pain if they're doing things that are causing other people pain. Automation, I'll show, this one that I'm going to get kind of practical on later on, but when you're talking about these small units of change, they're going to cause a lot of tedious work, right? You have to test each of those changes individually. The deployments, if you're doing a deployment every half an hour, you don't want a human doing that, right? You don't want a human having to click a button and watch logs scroll by every half an hour. That is a huge waste of their time. You have to automate that stuff. It's a ton of tedious stuff that adds up that makes this stuff work, and that tedium has to be automated. Humans are lazy. I kind of said this before. This is I think it's a universal truth, to be honest, and something that works really well with automation and kind of in the realm of the practices of DevOps is you use automation to make the right thing to do the easy thing to do. And then people will do the right thing. You don't have to force them, you don't have to threaten them. You just make it easier for them to go through the code review process than to try and go around it. And automation is a really key part of that. I saw that at a previous employer where security was a huge deal. And it could be a huge pain in the butt. One of the things was like keeping our instances, keeping our dependencies up to date. We had to keep dependencies up to date. We had to apply updates within like a week or so of basically when they came out from source control or from like a vendor or anything like that. And if a developer had to sit there and constantly just apply updates every single day, it would be a terrible job. It'd be very boring, and it'd be very kind of high friction. And what we did was just every week, there was an automated rebuild of the service that pulled in any dependency updates that were available and then just automatically deployed that. And a human didn't really have to do anything. And that is a hugely difficult technical bar for a lot of companies to get past. They really struggle to maintain and keep their software up to date. And this was something that it was totally hands-off for most of the development team. The only time we had to get involved was when something went wrong. And then we got immediate notification, and we could go and deal with it then. So automation is super powerful. I kind of said this before, humans are clumsy and they make mistakes. When you talk about doing that deployment every half an hour or something like that, people will screw that up. They will get tired and they will get bored and they will copy and paste and they will make a mess of things eventually. It is inevitable that a human will make a mistake when they are in the loop in this way. Automation protects you from those types of mistakes. I kind of put on here, computers are precise and they do exactly what they're told. Oh, I missed a do on that, but they do exactly what they're told, which is not the same as not making mistakes. There's kind of a joke that, computers allow us to make bigger mistakes faster than we ever have before. And that is true, but in terms of doing the same things over and over and over again, they are dramatically more reliable than a human is. So this automation, it really helps when you kind of have that process and those practices that you're trying to repeat over and over and over again, potentially dozens or hundreds of times per day. Microservice architectures, this is my warning flag up front, is the industry has kind of gone back and forth on this a little bit. Several years ago, Uber told everybody that microservices were the best, and they had thousands of them. And then a couple years after that, they said, wow, managing thousands of services is actually really painful. Maybe we should not be doing it this way. So I think the industry is still finding the perfect size of service, whether it is microservice or monolith or anything like that. But I wanted to call out here, they are really important. They are a core component of DevOps practices, but approach with caution. They're hard to do well. If your automation is bad, they will slow you down dramatically because you will have 10 times more services to be applying updates to and to be doing deployments of and to be testing. And if all of those things are not automated, this will be very, very painful for everybody. And another thing is that they can be costly too. In some cases, if you're doing like a true proper microservice architecture, each service needs its own database, for example, which can be quite expensive. So it's not for everybody, it's not for every company. So the reason though, why are they good? Why do you want to do them, right? They kind of have to be small to be fast, right? If you're deploying a service that is 2 gigs when it's deployed versus a service that's 200 megs, you just deploy faster, you build faster, you have fewer tests to run in a single build so they run faster. Everything about it, you kind of have to be smaller to be faster. And then there's kind of this interesting side effect of this, which is that if a service is designed to be small, that actually also makes it easier to scale, and it makes it more durable in a lot of cases. And the reason for that is that when you design for like a microservice architecture, you tend to design in a way that services kind of scale out horizontally is what it's called, where if you need to double how many requests per second you're handling, you just double the number of instances that you have deployed. You don't have to put them on a bigger computer, you don't have to give them a faster processor, you scale them out just by making more of the same thing. And that makes it very easy to scale, especially in like cloud environments where those resources are very elastic. But it also makes them more durable. If you're running 30 copies of your service and 2 of those servers die, it doesn't really matter. That's a super easy problem to handle because you have 28 other identical instances of your processor, of your server that can pick up the slack, can pick up whatever's going wrong there. So there's a nice kind of piece there as well. And then obviously, if you do want to have smaller teams, smaller services are just a better match. If you have a finite number of humans, those humans have to understand how the service works, and having a smaller service just makes that easier in general. I said I'd come back to infrastructure as code. I talked a little bit about this. Operating a service, if you are the operator, that means that you own the infrastructure. If you're practicing DevOps, that means that everyone, from the DevOps and the ops team, they're all going to own that infrastructure. Again, thankfully, that doesn't mean, for the most part, that people are having to physically build and rack servers anymore. It doesn't mean that someone on that team has to be responsible for understanding that in 2 months they will need a bigger server and placing the order ahead of time and handling all the logistics around that. Modern tools like infrastructure as code, like Azure and AWS and GCP, they give us the ability to own our infrastructure with a much less in-depth expertise. We don't have to know nearly as much to own that infrastructure as you have to know if you are physically running it yourself. And another piece of this is that infrastructure and configuration are super closely related. When you are deploying your application and you have a database server for it, telling the application how to access the database server, that type of configuration, understanding where your logs are going and how to get them back to your developers for that kind of monitoring and observability. That is a huge piece of configuration. That's something that those operations teams used to do, and it kind of makes more sense to have that in your software development lifecycle, have that close to your code. Here's my code, here's my infrastructure, here's the configuration that connects them. Having all those things together is just faster. It just takes friction and confusion out of the process to have them kind of close together. And then I kind of mentioned earlier as well, this also brings the benefit of you can now automate management of your infrastructure. And you can use existing software development tools like version control and Git code reviews and things like that in order to do better at managing your own infrastructure. And yeah, I kind of mentioned, monitoring again, right? So operating a service, if you are the operator, you have to know how that service performs. You have to know if it's fast or slow. You have to know if in the middle of the day when your traffic is the highest, if it is slowing down and needs to be changed in order to handle that traffic or not. You have to know if a new change has come out that has made things worse for your users, if it's slow, for something that's important. And it's critical to know how those changes impact users, and it's critical to know that for developers as fast as possible. So if you want to ship those small changes out quickly, you have to hear back immediately, users hated this thing, it made the app crash every 10 minutes, it makes it take up 10 times more RAM than it used to, things like that. All of those things, you have to know them, and you have to know them quickly as a developer to be able to safely move quickly. And yeah, I kind of mentioned that sympathy, you have to have a direct line. As a developer, you must have a direct line to those errors and to performance to build sympathy, to understand how your application is supposed to work. So yeah, the definition again, philosophies, practices, and tools, increasing an organization's ability to deliver applications and services at high velocity. I talked about the practices that kind of define DevOps. I'm going to talk a little bit about some tools. Now, if I were to talk about tools under every branch of the practices, we would be here for days. There are literally like multiple week-long courses that will talk about every tool under the sun for every one of these practices. So I'm going to focus on two kind of specific examples, which is continuous integration and continuous delivery. And I'm going to use those, I'm going to show those mostly through GitHub workflows. And CI/CD has been kind of the tooling that sort of defines DevOps. It is kind of the definition of how do we apply automation, how do we make things both safer and faster at the same time. Oh, that one did not update. So continuous integration, what does continuous integration mean? It is saying that proposed changes, if you are suggesting that you are going to make a change, that those changes should automatically be built to confirm that the software is valid at all, to know if you're going to get compiler errors or to know if it is going to work even a little bit. And then it should have testing. There's a whole set of tests that can run automatically that, again, they don't require a human to go in and click some buttons and know if something is going to work or not. You can automate these things and you can know very quickly if things are going to work as expected or not. So I'm going to switch over to GitHub in a second here. Oh, we had some chat. Do we have anything for me? No? Yeah, cool. So I'm going to switch over to GitHub in a second here, and I'll drill down into how this works. But I don't know if anybody here are familiar with like GitHub and kind of what it is, how it works, what it looks like to code PRs and stuff like that. The gist of it is that this is where the source code for your software can live. And when you're working on a team, you can work together. You can collaborate on your software together. This is an example of that where I have an existing code base and I'm going to propose a new feature for that code base. And that's called a pull request. I'm saying, please pull my changes into this kind of main branch that we're going to send to our customers. And down at the bottom, you can see there's these checks, right? Some checks haven't completed yet. This is my automatic build. So this is my continuous integration. This says anytime someone is proposing changes to the software, we don't even want to think about them until we know that they pass their tests and that they successfully build. And yeah, another developer could go in and they could build it, and they could go in and they could manually test it. And they would make mistakes because they're humans, and it would take them a long time, and it would add friction to the whole loop of getting this out in front of customers. So we're going to do our best to automate it. In this case, let's see. I kind of can show, if it fails, it's going to kind of go back to that initial developer, right? You can't send things to customers if your software doesn't build. No one else has to waste their time understanding if this thing works or not. If it works, then, you can feel confident, especially depending on how extensive your tests are. And this is something that you'll see a lot of like tests lead to confidence. And the better your tests are, the more confidence you're going to feel to smack that green button and say, ship it to customers, right? We're good to go. I know it's good to go because I know our automation and our testing is good enough that I don't have to waste my time and energy thinking about it and worrying about it. So I'm going to go through, I'll go through some continuous deployment as well, and then I'll jump back to GitHub and I'll show kind of the specifics of how this stuff actually wires together, which is pretty cool. Continuous delivery is kind of the next stage after continuous integration. So once you know that your software works, once you know that a new change is not going to break things for customers, what's kind of the next logical extension there is like, as soon as you pull that change in, send it straight to customers, right? You don't have to wait. You don't have to mail it to anybody. You don't have to wait till the end of the week or wait till Monday or anything like that. You can send it straight to customers. And a lot of companies will still have like that one last minute of like, someone still has to check a box. Like, it will make it super easy. I've seen Slack bots that'll do it where, like chat bots where they'll message you and they'll say like, hey, do you want to send this out to prod right now? It's like, yeah, sure, go for it. And they make it really easy again through that kind of automation, but you can just send it straight out. This is an example of what's called a GitHub workflow, where we basically just say as soon as anything changes in our main development branch, send it straight to prod. Deploy it right away. Don't wait around at all. I should actually be able to show exactly how that works. Yeah, so we'll jump to that in a second. Yeah, we'll jump to that.
Good job.
4 minutes. I can cover most of this in 4 minutes. So let me see. Can everybody still see on the Zoom the screen share here of the browser? So I put together a quick little application the other day that is just it's a little web server. That might be a little hard to read on the screen share, but it's a little web server that just runs. It has a couple endpoints where it just kind of repeats your name back to you. It says hi, and it'll reverse when it repeats your name to you. It'll write it backwards when it sends it back to you. And with this, we have a couple of tests. This one's just really simple. Hey, if I put in this string, I expect it to come back backwards. Pretty straightforward. Run it, check if it meets what we expect it to, and either pass or fail as a result. So then if I go over here to where I've proposed a change, I said, hey, let's add another endpoint. Let's add one that says goodbye. And if I look at my running build here, I can see that this one did my build, did my unit tests, all my tests passed. I would feel pretty confident to just merge this and send it straight to production. I'll show as well here what that actual workflow looks like. So this is what a CI kind of looks like on GitHub today. We're going to say, hey, when either somebody clicks a button or when somebody opens a pull request, we're going to grab an Ubuntu machine, Ubuntu Linux, and then do these steps. Check out my code, set up the Golang compiler, which was the language that I used here, so just set up my language compiler, build it, and run my unit tests, and that's it. And as long as none of these return an error code, put that green check mark on there that says, I think this is good to go. And you'll see lots of different steps sometimes in here. But that's a pretty straightforward kind of CI there. And then we're on a limited time here, so I'm going to show another CD one real quick. It's that continuous delivery one. I have a PR. This is on a different service. It's actually one of the chat bots that's on our Sault Ste. Marie developers Discord server. And what I was finding was that the images were expiring too quickly when you asked it to draw you a picture. So I'm rehosting them. And I'm going to squash and merge. And we can see on this one, it has that deployment And we can see that it's deploying right now straight to customers. So that feedback loop of make changes and send them straight to customers can be super short and super small. And with the right kind of testing and automation, it can actually be very safe to do that. So I think our Zoom call is ended, or is just about to end. What's that? What? Okay, less than a minute. Thanks, everybody. Send me messages. Join the Discord. Ask questions. I'm not going to run off the stage the second that Zoom call ends, so we can run through any of this stuff on GitHub, on workflows. I can look at some other systems, whatever we want. So thank you so much, people on Zoom, for coming out. I'm sorry that it's about to end on us. Boom! Timing!
Right on time, too. Right on time.